Good evening, sir. I think your voice is a little low, sir. We are unable to hear you properly.
Are able to hear me now?
Yes, sir. Now it's clear. Yes, sir. Good evening, sir. Yes, we'll start by five exactly. Yeah. Are you
Logging in.
sharing any screen, sir?
Yeah, I'll be sharing a screen.
Yes.
I'll also log in through one more system. Okay.
Sure, sir. Sure.
I'll give a different name so that you can admit me. But I need to be as a only a attendee.
Yes, sir.
Sir, we will be running the sponsors week. After that, we will be starting.
Sure. Yes. Okay.
Yeah, go ahead. Go ahead.
Yes, sir. Thank you.
Tendarajan sir, you can go ahead now, sir.
Yes. So, sir, shall we go ahead, sir?
Hello, sir.
So, sir, Gangadharan sir, shall we go ahead?
Yeah, please go ahead.
So, good evening, ladies and gentlemen. We welcome you all to another interesting session of Research Scholars Day 2021. RSD 2021 has started with a wide range of events from lecture series to interactive talks and workshop to competitions. It aims to bring together people from different research backgrounds and encourage exchange of ideas and research interest. I am very pleased and honored to introduce our speaker for this session, Dr. K. V. Gangadharan sir. Thank you for joining with us, sir. Dr. K. V. Gangadharan sir is professor in mechanical engineering and head for Center for System Design, President Institute Innovation Council, National Institute of Technology, Karnataka, Surat, India. He has IITMADRAS in the year of 2001 in the area of railroad vehicle dynamics and ME from NIT Trichy 1992. BTech in Mechanical Engineering from Calicut University in 1989. His area of interest are system design, vibration and its control, smart materials and its applications, and so structural health monitoring and product design. He is also actively involved and engaged in creating learning material for experimental learning for basic concepts in engineering. He has teaching and research experience of 27 years and industrial experience of 1 year. He is actively engaged in industrial consultancy and sponsored project and has more than 120 research publications on his credit. He is also filed 7 patents, 4 in the area of medical devices and 3 in smart material applications. Also active HIM amateur radio with call sign of BU280O, in charge of amateur radio faculty in NIT Surat. Today's the title talk is in the experimental learning, basic steps towards research and online approach. Now I'd like to invite Professor K. V. Gangadharan sir to deliver his interactive talk. Over to you, sir.
Sir, sorry to interrupt. There was some disruption and disturbance in the audio. So I would request you to put the video and audio on.
I need to mute.
Quite a bit of disturbance in the audio. I hope you are able to hear my audio now, okay?
Yes, sir, your audio is okay.
So, a good evening to everyone. And it's an happy occasion for an alumni of IIT Madras to come back, and even though in the virtual mode, to talk to the research scholars and others, those who are listening online as well as on Zoom. So let me just start with my presentation. Hope you are able to see my presentation screen there.
Yes, sir, it's visible.
I also have my side, another system wherein I can see what others are seeing. So very pleasant good evening from on behalf of National Institute of Technology, Karnataka, Surat, which gives me my bread and butter. So we are an institute on the seaside and very environmentally conscious. We hope to have a carbon neutral campus in the due time, the course of time. Today, I thought of giving you a very, very light talk on experiential learning, a basic step towards research and an online approach. So I'm sure that morning I also listened to some of the talks. I know research scholars are expecting quite intensive math-oriented talks, whereas I thought in the evening I'll make it light and make sure that we get something out of this light talk and relook at the way in which we look at our research. So that's the intention. So we are looking at experiential learning. So thank you, IITM RSD team, inviting me to showcase what NITK is doing in this domain. So that way, on behalf of NITK and NITK Center for System Design team, we are quite thankful to the team who invited us, the Research Scholars Day team invited us. This is what the abstract I gave. I said, knowing more and more about less and less is what research is all about. Of course, it is debatable. And how do we make this more experiential is the question which we are going to ask. To take you to that, I need some base on which I need to start with. I'm sure you are all familiar with the year being notated as BC and AD. And I am also sure that you know, presently we are being notated as before COVID, and presently we are going through during COVID, and hopefully the green arrow comes close, and that is going to be after COVID. And we have changed a lot. With whatever minimum resources available, when we were locked in our home, we still continue to teach, learn, and do research. Did we really change is the question. Let us look at, did we evolve? We have evolved. So we have evolved from an ape to similar looking creature here. Fortunately, it's a man. I forgot to clothe him. But we have evolved. And the question is, are we coming back to the same shape and size? If you look at transportation, I'm sure all of you recognize the evolution. Communication, it's quite evident. I'm sure many of these devices are not known to the millennium kids. And looking at the kind of phones, the phone, if it falls on the tile breaks. And the latest Apple phone, if it falls, of course, the wire's heart breaks. So we have changed. And 1G to 5G, we have changed, even though we remember 2G for a different reason. And computation also, computing has already evolved, but something which has given us some physics background, look at the picture. Hope you are able to recollect something which you learned in physics very clearly. The mass conservation. The devices become thinner and thinner, the person who operates have become fatter and fatter. And we have all the connected devices, body area network, LAN. After LAN, we have WAN, then also WAN, BS, body area network. So we have devices connected around the body now. Did we change? Is this change for F to ape or reverse? You can put your own arrows, whichever you like, whether you want to say from Facebook to the ape or ape to Facebook. So when we look at have we changed, you can see the picture where people have to be guided to cross the road. Believe me, they are not blind, but they are glued to their 5-inch screen. And they don't see the beauty around. They are so much glued to the 5-inch screen where they believe the entire cosmos is. And we have changed our signboards. Whether it is reality or augmented reality or virtual reality, we are the same. We keep peeping out and seeing what is really happening. Did our classroom change? I'm sure you will recognize this. They did not have a color picture, color photography in the beginning, hence it looks black and white. Otherwise, you can see it is same. And we teachers knew how to keep you quiet by making the force or showing the fist. And we are so good in evaluating each one, be it a flying one or crawling one or assuming one, everyone, we have been giving same kind of test, whether it is a social science research or it's an research in engineering or in pure maths. We say we need 2 SCI index, SCI journal paper, and that's it. Nothing else is going to satisfy me to say that you have done the research. So climbing the tree is the ultimate to say that this the same way we evaluate results. And each individual and the topic and the domain could be quite different. The fish in the water, or the crow in the air, or the monkey which can climb. Everyone, you understand this as the topic and the research scholar, we evaluate in a very, very similar way. And we claim that is a fair method of evaluating is what we are doing it. We can again debate, is it really helping us or troubling us? And we also make fun of the creature who could not climb the tree and say that it is useless. And we also know nothing is useless, everything is used less. Now from here, let us take an example of a common statement and see whether we find a research potential. Remember the topic which we are looking at, how do we get an experiential learning to aid our research? That's a topic. Wherein I will just get you 1 or 2 unstructured problem statement, see whether we are able to get something out of it. To see, I'm giving you simple statements because it's an heterogeneous group, hence I don't want to put any specific scientific things as an unstructured problem statement. Let me just choose one statement from 1990 Africa. I'm sure you are able to understand the symbol which is given there. One of the predominant issue was AIDS, and there was only one way to contain it by spreading the information what to do and what not to do in South African countries. And the only mode that could get the communication across was the village radios in the village. And obviously, people from Western world, philanthropists came and distributed radio to every house. Okay, and they also made sure that transmission is in the local language, and also they made sure that they have sufficient entertainment program along with that information about what to do and what not to do to avoid spreading AIDS are also informed. After 3 months, the people came to verify whether their donation was effective or not. And to their utter surprise, they saw that nobody was using the radio. I think you might have disabled the chat, but I'll say, okay, you don't need to say anything. Just think about it for next 30 seconds, why the villagers did not use the radio. They had entertainment programs, they had information, and do's and don'ts in the local language was available. And it was in very comfortable time. Those who are going for work, they were avoiding that time. All that was taken care, but still, the radio receivers were not in use after 3 months when they went and checked. What could be the reason? The person who went there, one of them was Wailis, who was an aquatic trainer, a trainer in a swimming pool. He went around and found that he found a relation between AIDS and energy. Look at this. Don't giggle on when I say AIDS and energy. I'm talking about energy, the power, and electricity. Can you connect AIDS and electricity? In fact, that's what this person did. He saw that the radios were not used because they did not have sufficient money. Those who cannot just afford a square meal, cannot afford or look for getting 2A batteries, 2 numbers in order to listen to the radio. So he found out a simple method of energizing this radio from available information. He did not invent anything new, and he wasn't an engineer as such. So what he did is he used the wind-up approach to store potential energy in a spring and use that potential energy to get converted into kinetic energy and drive a small generator which will power the radio for 2 minutes of winding up will give them almost 1.5 hours of power required to run the radio. Look at the connection. Wind-up mechanism was available. The domain which we are now talking is infectious disease or transmittable disease. And we are connecting that with communication. Then communication got connected with power. And to get the power, we are now looking back to the basic physics and got something else done. Look at the research potential all around. Even though it looks very simple, there are sufficient amount of social science research involved, how people behave, what they do, etc. Plus, you also look at how we are looking at the technology or information which we already have can be used for multiple applications. And it is not necessary that it should be done by an engineer or a scientific person. A person who was just doing training in a swimming pool was a person who did this. The question here is, are we missing this kind of an approach in our research? Are we asking the right question, or are we looking at the right solution? We might have asked the right question, but the right solution. I'll take another example. Again, I will take it from a domain such a way that it's not very complex. Look at carrying the load. This is possible when you are sitting in a team of research scholars. Ask them the question, how do we help them? Obviously, the solutions are existing, hence it is easy to find. But what we are looking at is, are they also able to find what basic physics has been applied in order to do this? Look at the solutions. It's a sustainable solution and environmentally friendly solution, wherein using bamboo sticks and few other materials they have made this. And look at these three pictures and try to find what is the basic physics used to reduce the pain of carrying the load. They still carry the load in both the pictures, and the third picture, it is getting rolled. So look at what is that the basic understanding of our basic physics has been applied for a solution. I'm sure that all of you have identified that here in the first case. Let me just put the laser pointer. In the first case, here the area through which the force is acting has been widened. We have used the same equation, F by A, force divided by the area, as very large. And if you want to connect it with mythology, look at Mahabharata and Bhishma Pitamaha on a bed of arrows. So same principle which is reused here in order to reduce the pain. Look at the second picture, this picture, where we have used something called the mass being close to the CG. Mass being close to the CG, so that the arm length of the moment, R into F or F into R, that R we are able to reduce. And the third picture, it is, why should I carry? I can roll it. The rolling friction is much easier to tackle rather than dragging it or keeping it on the head. So look at this way of looking at a problem statement. Help me to carry the load become some product or a process. When you have to create a product, a lot of things goes behind. What material to use? Is this material sufficient? What cross-section to be used? What kind of load comes on? Is it dynamically safe? Whether the static analysis need to be conducted? All that happens to be the normal thing which we need to do. So it becomes part of the research. I have taken a simple problem to explain in the talk, whereas it can be extended depending upon the domain. It can be taken, the problem statement can be taken from the corresponding domain. So this was from NID, National Institute of Design. In fact, this product was a third semester assignment for Vikram Thirubhai, and later he took a patent as well as made it open to everyone to use. Similarly, and the research opportunity in many of the North Indian states, fairly okay road may be there, but water network may not be there. That potable water may not be there. And this is a very common sight in many places. Even for some places in Tamil Nadu also, it is quite common. So how do we carry this? I'm just getting into avoiding this and getting into the solution. Look at this and find research opportunities. I'm looking at a material that can be used as a port. That port itself will act as a wheel, and I should be able to put it in such a way that I can roll it around, and I need it to be as light as possible. Look at this picture. This boy is carrying it. Of course, it is empty, carrying it like this. So the problem statement could be looking very innocent, not having any research opportunity, but we should be able to find solutions. To reach the solution, we may have to do a lot of research. So I'm looking at this problem and its solution. For that, we are doing research. It is not the other way. I have done set of research and I have the solutions available. Now I look for the problem. Okay. So here, all these places we have used existing understanding. Okay. Existing understanding alone. Now, those who are not happy with the kind of problems which I have taken, I'll straight away get into what I meant by an experiential learning, try to connect it with one or two examples for the common understanding of an engineering or a science background person. I'm sure that many of you do research in robotics. And I'm now looking at research in robotics as an activity. And in Indian research, it is like an arranged marriage. You get into an institute, find a suitable gate, find a gate and make him suitable. Then he probably gives you an area and we get into that. So it is more like an typical Indian arranged marriage where we get married and start loving. So in that condition, somebody has come to robotics as his passionate area, and he happened to be a mechanical engineer, the person who was going to guide, and he's good at something else. And obviously the student has been assigned and hence looking at things. So the student was very clear he wanted to do something on robotics. So now the question is robotics is all about DSP, electronics, drives and motors, or is it has something to do with mechanical engineering or basic physics, or is it to do more with communication, or is it an interdisciplinary or a transdisciplinary activity? So assume that the guide wanted to impress upon the student to say that you are working on robotics, but my focus area is slightly different. I want you to work on a gripper. Obviously, that is again from the robotics area. The person who came, assume that the person who came to that is an electronics student. Okay, so he is looking at what is a gripper to do and how he can do a research in it. Okay, just look at the slides. Started looking at the basic fundamentals and trying to simulate what happens when things are moving, etc. What kind of input need to be given in order to create the required response of the movement. This is very, very close to your H omega, that is transfer function. Here, in each of these cases, only one rotation is the input. And much complex response output are able to be made. Or if you are looking at a gate, just by one rotation, with appropriate activity, you should be able to recreate the gate or gate motion. Now, remember the guide has already asked you to do on research on gripper, and you are obviously looking at gripper, how do I make it adaptive and make sure that whether I hold an egg or hold 1 kg of metal should be able to hold it appropriately, and all that was your thing. And you are looking at how do I make it more smart and things of that kind. But to reach there, you need to first make a gripper, and you are not from that domain. So this is how the gripper can be, one approach. Now, I need the student who is from another domain get into this, because this is not his major work. He need to make it, but then he is going to add sensors. Probably he will have n number of sensors, will do a sensor fusion, use artificial intelligence to make sure that the data what he gets is modeled and given appropriate response. All that complexity we are adding. But to start with, he need to understand how this can be designed or made. If he is not in an interdisciplinary lab where he gets the help from others, at least even if that is there, he may have to get the understanding of how is it functioning. Now, for this, you can very well use the basic things like this, the building block. Those who are from mechanical or similar background will understand these were the basic building block which we used to make this gripper. Okay, we will not dwell much about what is it, but this is to communicate that yes, even in from a different domain, when a person comes, probably we need basics of other domains to be experienced to make our research much better. Okay. From there, probably I'll also just demonstrate one simple thing of sewing machine. Just look at the sewing machine. Try to look at it from a research perspective. Okay. I want you to think about the kind of input you give and a box and a response. Okay. The system perspective. Look at what you're doing in a sewing. I have the needle going up and down. There is 2 threads and thread has to get entangled and it has to have the sufficient tension to make sure that one is not loose. All that has to be done. And this has to be done with one input, remember. So you have only one input which you are going to give, that is a pedal swing. And that swing you need to modify in such a way that needle moves up and down, cloth moves forward after each stitch, and pedal swing is converted to rotation in order to achieve all this. Are you able to find some relation with many of our system statements in this? We have one input is getting modified to required responses and get the final requirement. So it is not necessary that you need to look at very complex system to understand these basics. If you are able to experience this concept of system approach, probably we will be looking at research in a different way. So this is a double-threaded sewing which happens normally. Okay. So from here, we'll see how do we do it in an actual practice. So experiential learning, how do we implement that too in this difficult time? We are looking at how do we make it online. So let us see. So I'm going to give you a degree in swimming after 3 years, but I'll make you to sit on the side and give you all the equations, buoyancy, how you need to float, what is the force you need to give to move forward. Every equation you have learned, you know how to derive it. You know all the parametric studies which can be done in a computer. So you have beautiful running graphs, colored graphs saying that if mass as a parameter changes, what happens? If the arm swing changes, what happens? At the speed, etc., etc. So all that is done. And at the end, I will give you a degree and ask you to swim. I know you are giggling at me. In fact, that's what exactly we do. Many times, we make our students to read engineering or science rather than do engineering or science. And that is true even in social or humanities side. But they do little more because those subjects are much more close to the heart than to the brain. So can we make the students, researchers, or learners to do engineering and science rather than reading engineering and science? That too in the difficult situation like this, where they may not even have close access to the laboratory. If you look at gurus, I'm sure this is either in the picture or in the textbook. And we have been doing dhyana with all this now. And our young smart people are quite happy with the loves and likes which they get for their postings. The question is, can we use the same medium for experiential learning of the basic concepts so that I can plunge into research in much better way? I get more philosophical approach towards the topic which I do, PhD. So you become philosopher in that small domain which you are working on. So you're coming from a wide area, getting down, narrowing down, knowing everything about nothing is what is going to happen. And for that, can we have an online activity which will help you to get that experience for the learning activity? So when you talk about experiential learning, I'm sure all of you look at these kind of pictures come to your mind. And be ready for this. If you want to avoid this, one method, it may not be a replacement, but one method to augment your experiential learning is to get into a connected device and do things on that. Is there an opportunity for each one of you to do that? Is the question next. So let us now start dreaming. It's a nice time to dream, 5 o'clock or 5:30, and you can grow as big as your dream is. So let us dream. So you can be an administrator who are listening, or you can be a professor, or you can be a researcher. So I'm going to dream about a lab, which is at my place, my pace, and my period. So can you think about a lab at your place, wherever you are, and at your pace? If you want to conduct experiments and learn the basics, you should be able to do that, and that too without any time restrictions. And at your period, assume that you are a Rakshasa active after 12 o'clock midnight, and you want to conduct an experiment. Don't ask me what experiment. You want to conduct an experiment at midnight. It should be possible. Remember, it is a specification for the dream. So we are dreaming out a lab and probably a learning management system at my place, my pace, and my period. Not that enough? I want this lab to be the way in which I can take home or carry with me. And I don't want any lock and key and no holidays. And the lab that helps me, especially maybe for a PhD or a research scholar, it may not really matter the syllabus because he decides the syllabus rather. But it obviously matters the dream job. Can I get a lab which will help me to strengthen my basics so that I can get into a job? Or if you're already on a job, you want to change the job and look at a new area, etc. Can I dream about a lab which will do all this? So look at the specification we have put for our dream. So remember to put specification for your dream and make sure that you achieve each of that so that you achieve the dream. And the dream, what Ministry of Education, earlier it is known as Ministry of Human Resource and Development, has done is they created virtual lab. You can see that all 7 IITs are there, and among NITs, NIDK, COEP Pune, Dayalbagh, and Amrita University, and IIT Hyderabad, along with IIT Hyderabad, along with other 7 IITs, together made something called virtual lab. And things are very simple. There are 3 different kinds of lab available, which is modeling or simulation-based labs. If the equations or parameter variations are known quite well, you can create an equation and you can add some white noise to create it as an experiment, and that is simulation-based lab. Or something like an universal testing machine, you are breaking a component, finding out the strength, you want to do it for 100 different material, conduct all that experiment of different materials, store it as a database, and when the user comes, he will get an appropriate measured data as an output. That is measurement based. Or king of all labs are remote triggered lab. Think about doing your research experiment, sitting at your comfortable place, just hooking on to your mobile phone, switching on, switching off, adjusting the parameter, getting the data without even visiting the lab. That is called remote triggered lab. So this approach, most of us has implemented at many of the places, and quite successfully it is demonstrated that it is possible to do all 3 different kind of laboratory. We'll just demonstrate 1 or 2 just to get a feel of it, and then I'll also be talking about what we do as an interdisciplinary or transdisciplinary center. I'm just taking the tab where I can show you what is virtual lab. So this is Ministry of Education's virtual lab. And you can look at, remember, quite often during research, we have a small, very trivial question to be answered. And we feel very difficult to go and ask another domain person, what is it? Or probably we need that help just after reading a paper. I want to know why a diode is kept in one circuit as a flywheel diode, but that is not explained in the paper. If I can go back to some basics in electronics or electronic circuit, I can get it, then that saves my time as a researcher. So is it possible to do that is the question. And if you are able to do that, your time is saved. You get a better understanding, experiential way of getting things on basics. So that strengthens your research approach. So we'll just look at one or two experiments. I'm taking the clue saying that an electronics engineer happened to do a gripper, research on a gripper, and he was forced to make a gripper as such. Okay, and he had to use some of the basic mechanical things. So look at this diagram. I hope you are able to see the diagram. It's a simple mechanism, and we are able to give all the complex things there: displacement, velocity, and acceleration. And I can also change all the parameters and see whether I'm able to do variations. So I can change R, L, and omega. All that can be changed. And I can get the variations. Similarly, this is available in mechanics of machines in mechanical lab. So you see, you will have basic theory. Some basic theory will be given, very brief. And it's meant for people who are in a hurry to get the basic understanding. And simple procedure is also given, which may not be required many times. Then if you want to know what is your present level of understanding, you can set a self-evaluation. Remember, it is not known to others. It is you only know. Out of 10 marks, how many you are able to answer. Then you do a simulation study. There are different methods on simulation. Then if you are interested, you can do an analysis. Then you can again do a quiz after doing this to understand what is the delta X which you could get. And there is also a spoken tutorial as well as the videos available on this itself. So this is one type of experiment available online. Another type is remote triggered experiments. Assume that you would like to do an experiment on a simple pendulum. I'll just connect this. So here, I think from my lab, this is from my lab, which is called SOLVE, Students Online Laboratory through Virtual Experimentation. Behind we had a green curtain. Probably one of the PhD students want to take video of his experiment, hence he has taken it. Otherwise, there was a green curtain behind it. So you can see this. So I'm going to trigger this experiment first. There is absolutely no login. Any one of you can try out rtlabs@nitk.ac.in, and there is no login requirement. Yeah, you can see the setup triggering. Once it triggers, it gives you the data. You have the data available now. You can download this data, and you can also change some parameter. So let me change the parameter, the length as a parameter. I am just keeping it small. Change the length. I'm keeping it small, so the green portion here should go up. It has gone up. Okay, I can conduct one more test and see what change I get. Remember, we are triggering the experiment once again. So it has triggered, it gave me one more set of data. Remember, it is an actual experiment, and you will have data 1 and data 2. Now I'll change the length to the maximum. Let us see the change in length. Please look at the ball which is coming down, the bob which is coming down. Once it comes down, we'll do one more trigger. I think I have two more minutes to go. Here it shows me how much more time I have, the control given to me. Depending upon the experiment, we decide for 3 trials how much time a student may require. So I'll get data 1, data 2, and data 3. You can download this data and you can do the analysis. Of course, we have made sure that the system is kept as simple as possible. And you can proceed to calculation. It will ask you a few questions. You can enter the data. Or if you want, you can download this data and do your own analysis and find what you have learned from this. Now, in this, let me just go back here and start this to show you we have made this experiment using an interdisciplinary approach. In fact, this was created, it's very simple, but it was created by students with the help of research scholars. We have kept a DC motor, and once it is given the rotation, after that, when it is oscillating, the rotor is also oscillating. We made use of that and made it as a generator, and depending upon how much resistance I give, I can increase or reduce the damping. Look at the system parameter modification which we are looking at. And we also use some of the computer engineering students to implement, in a compiler design, I'm sure that the computer engineers quite well know, they do a lot of things to do with exception handling. When you put a floppy or a drive, it says a drive not detected or file not found, all those kind of things, interrupts and things of that kind. All that at the hardware level, we try to implement on this. Look at now, a computer engineer working with a mechanical person, with an electrical student, working on to create a lab which is accessible from everywhere. So this kind of approaches helped us in making sure that we have right kind of a group to work together, and all of them experience the basic concept. So they are able to help each other, as well as they are able to look at the problem statement in a much better way. So from here, let me just go back to my presentation. So this is what we created, Center for System Design, wherein we made sure that every one of them gets an opportunity to look at different kind of problem statements. We did something called Smart City. I think Gangadharan, when he was an MTech student here, he had opportunity to work with these kind of projects. And many of these projects are interdisciplinary, and they keep looking at it as there will be a PhD student, MTech student, and some BTech students. The group will be in such a way that it is so heterogeneous. They keep fighting to make sure others understand what they are. And that is one of the major part when it comes to research. Are you able to convince others about your idea? So be it control system, but everything has to be done by them. That means we create doing engineers rather than reading engineers. We also work on software-defined radios and amateur radio, where we do have facility to transmit and receive. And we conduct a lot of tests for many of these dynamic systems, roller coasters and things of that kind. So that is about how did we create that. And are we just looking at only that, or we have things more to do with? I think I should give, this is an interactive session, I should give some time for interaction. So what I'll do is, I'll just look at the interaction portion. Then I'll have one more slide to show at the end. So I'll unshare. Yeah, if you have any interaction at this stage, I'm willing to take. Then we can go further and see whether we have some questions coming afterwards. And you can also go through the research expo, which RSD has put. There we have put few of the videos. And you can also go back to Center for System Design's YouTube channel. Each of the 2 minutes video which we have put have sufficient amount of story behind it. And we have done multiple research, and all that research together, we made it as a single video as that. Because I insist my students to make a video for 2 minutes to his or her grandmother what is the research he did. So that we call it as thesis in 2 minutes to your grandmother. Thesis in 2 minutes to your grandmother. If you are able to talk about your thesis to your grandmother, then you have understood the area which you have worked in. So you have become the philosopher of that. Or if you still need equations and diagrams to talk about your research area, you are still in the beginning stage. So that's what we have been trying out all the time. Now, if I'm lucky to get some questions, I can take it. Otherwise, I can continue with one more slide.
Sir, Arnav here. Good afternoon,
Yeah.
sir. Sir, I have just one thing to ask. Like, while we are conducting an experiment in the lab, be it at UG level or PG level, we get a taste of for a particular experiment, what all things we need to assemble and how we need to assemble those particular things so that the experiment runs successfully. Successfully or not, that is the latter part, but it runs. So in the virtual lab, do we have such a provision where the student gets a chance to assemble the different items that he will be needing for a particular experiment?
Exactly. I mean, this was a question we also kept on asking. And not only that, can I make mistake? In a regular lab, you are not allowed to make a mistake. You cannot take anything a speed which is greater than what is allowed. So in a virtual environment, the understanding is you are not really putting anybody's life into threat in doing an experiment, because whatever parameter you want to change, only equations are taken care and no explosion happens. Hence, we are able to take care of you making a mistake, or the learner making a mistake in the virtual lab. One. Second, you can plug and play and put items together and see whether it is working. And for example, you can just go to IIT Guwahati's electrical machine lab. You can configure a machine as an induction motor or an DC motor or even different kinds of motors and give different kind of input and see what happens. Sometimes it may run, sometimes it may not run. But in a normal laboratory, what happens is we give all the diagrams and say that just follow this line, do it, and draw the line, draw the diagram, the efficiency graph. If you remember, from 1960 onwards, everybody in that institute is getting the same graph. I mean, I'm talking about NITK because we are born in 1960. So from there onwards, my engine graph was the same. There was no difference. Whereas in a virtual lab environment, because we are able to play with parameters, it is very easy to make such modifications. And we can also give random errors. That is another advantage. Putting a white noise in a sine wave is very easy. And I can even change the parameters in the error and see whether the student is able to conclude appropriately. Those are the advantages without troubling anyone. Without really going to the lab, you will be able to do. You can experience what happens when a parameter changes.
Yes, sir. Sir, actually, I also experienced one such thing in a fair, in a science fair. So there they have assembled a virtual setup for welding.
Welding, yeah.
Yeah, so they were varying the current and voltage to ranges beyond the practical range and showing like what can happen to the material and all. So yeah, it was a good learning experience, and yeah, if we can integrate it in the virtual lab for the students, scholars, and all, it will be.
It is done. In fact, when you said welding, I don't know how many mechanical people are listening. Overhead welding, and what happens if it is a DC welding is used? Positive terminal, what is a heat content, and the negative terminal, what is the heat content? 2/3 and 1/3. So if it is an overhead welding, where I should have the positive, where I should have the negative. And all this become an experience when you are doing it on an experiment at your own comfortable time. Because in the lab, normally a group of students go inside and somebody instructs you to do something and you finish it and come back. Because if you are a slow learner, you feel hesitant to ask questions. If you are a fast learner, you find it is boring because everybody taking too much of a time. So those kind of things can be overcome using virtual lab as an experiential module for basic learning or learning of basics in research environment.
Yes, sir. Thank you.
Any other questions? Otherwise, I have something else to show before I continue.
Yes, sir. Once again, Gangadharan, sir. Thank you so much for the opportunities sir, when I was there in CSD lab during my graduation, post-graduation work. And that was great moment where I learned many things, especially like other subject, design subject, when we take there are a lot of mathematics and other things involved. And I took background, industry background, I used to get it. Not much usual mathematics, but you made me experience again in the lab, and we used to create some product in the research also in parallel, something kind. So that is a great experience we had, sir. And in CSD and the Star Lab is the source where students learn many practical way, and they produce the product. That's what I got experience from our CSD lab, sir. So once again, thanks for I take this opportunity through this meet as well, sir.
Okay. So before you officially conclude, I want to show one more slide. Then I can conclude.
Yes,
Sure, sir. We will go ahead.
So I'll once again
Sure,
screen. You're able to see my screen. Okay. Give me a moment. I think I just came out of the PPT. I'll just come back with that PPT. Give me one moment. I'm just getting back my I think I'm back with the PPT. So this is about research, and I'm unmute. No? So this was a problem statement where a car fell down in a river, and a normal crane came to take the car. Okay, so for a crane, it's a normal work. This happens, and they are happy. And likewise, researchers are happy when we get a problem. So we did not have plastics, and we created plastic as an output of research and created a bigger problem. And we are trying to solve that now. Similarly, here the car fell down, and a crane, the tool came in order to solve the problem. And for such a problem, the crane was sufficient. It was something very simple. And a linear analysis was enough to solve this. Hence, we applied the linear analysis, appropriate tools, all that we did. And there was absolutely nothing to worry. And problem is about to be solved. And we are in the final pre-synopsis condition or a synopsis condition. And look at what happens. Now you realize what is that you didn't take care, why the results came so wrong. So it was a simple problem, but finally the answer or the conclusion was disastrous. So obviously your research guide have given you ultimatum saying that no, what you have done is pure linear analysis, but your system was behaving non-linear. Hence you need a much more sophisticated tool. Obviously you started searching and you got a very sophisticated tool which can do much complex analysis. And you had the first problem statement, remember, and that was easily solved. But the gate was sharp enough, your Guruji was sharp enough. He said, anyway, you have created one more problem because you have broken something and put it together. Please solve that, then submit your thesis and go. Quite often that happens when we have solved something, we found a much bigger problem aside. Obviously, we will have the inquisitiveness to, can I solve even that? So now the small problem is solved. Remember, your basics were the same. You were as clear as earlier when the initial tool failed. And you solved the big, smaller problem which you have taken up in the beginning. But now you have much better confidence because you are using much complex tool which can do much more things. Hence, you are attempting the next problem also. So the problem which we have created now and that need to be attempted to solve. And remember, we have the same basics and see what happens. So this is a point where we would like to highlight. Your tool can do as much understanding as you have. Tool may give you more options, more complex analysis. Unless and otherwise we are strong in the basics, any complex tool is going to give you wrong thing. So you saw the first linear analysis gave you a wrong result, and that was a catastrophe. Finally, you learned a bigger tool to operate, and even there, you found out it is miserable just because you did not know how to take care of simple CG, or the learner or the researcher did not know how to take care of the CG. And this is what happens quite often at the end of the research when our basics are very, very, very poor. And to avoid such situations, we would strongly recommend get into experiential learning. Get into experiential learning so that you know the basics very clearly. On that, adding whether it is linear analysis or non-linear analysis become a happy moment. Otherwise, it's going to be all with a very poor foundation. We are trying to make a large building and a huge structure over that. So my strong suggestion to all the research scholars is get into experiential learning. Every basic step, please experience it yourself. Then you can become a philosopher in the domain which you are working. Thank you very much for a patient listening. Hope I have made it as light as possible with no equations and no huge amount of what we did kind of a statement I have made to make sure that it is as light as possible for an evening talk. Thank you very much for this opportunity, and look at the experiential learning as a real activity to make your research better. Thank you. Yeah, I'm closed. I have closed the talk.